This is our second video on exponent rules. We are going to be taking a look at how to deal with negative exponents and how to deal with division with exponents today. So negative exponents, when you have a negative exponent in your numerator, you're going to take that term and move it to the denominator, and the exponent's going to become positive. If it was in the denominator, the negative exponent, you would move that to the numerator, and the exponent again would become positive. We're only moving the negative exponents. If you have a positive exponent, just leave it alone. So the way we write this rule is if you have x to the power of negative a, that becomes 1 over x to a positive a. And this rule works both ways. So if we started with 1 over x to the power of negative a, if that negative was in the denominator, we are going to take that a and move it to the numerator. So I have x to the positive a, and that's just over 1. And then that just equals x to the power of a. So we're just flipping the direction of wherever that negative exponent was. If it's in the numerator, it goes to the denominator. Denominator, it goes to the numerator. So number 1 here, we have 2x to the negative 3. If we look, that negative exponent is only on the x, so I'm only moving that x to the negative 3. So 2 stays in my numerator, x to the negative 3, putting the x in the denominator, and that's going to become positive 3. There's nothing else I can simplify here, so that is going to be my final answer. So basically, we just want to get it to a point where we don't have a negative exponent anymore, and everything in the fraction that can be simplified is simplified. Our second problem, we have x to the 7th, y to the negative 2 in the numerator. Denominator, we have x to the negative 8th, x to the negative 2. So we're going to start by just flipping everything that has a negative exponent. So x to the 7th is staying in the numerator. If we look over here, we have a y to the negative 2. We're going to move that to the denominator and make it to a positive 2. Down in the denominator, we have x to the negative 8th. We're going to move that to the numerator and make it a positive 8. And then we also have x to the negative 2. We're going to make that x to the positive 2. So I've moved everything with a negative exponent. Now I'm going to start simplifying. If we look in the numerator, we have all these x's to different exponents being multiplied. Remember that when you're multiplying and you have exponents like that, we add those exponents. So it's going to be x to the power of 7 plus 8 plus 2. And that's all over y squared. If we add those exponents together, we get x to the power of 17 over y squared. And that is where we're going to leave our answer. We can't simplify any farther, so we just leave it like this. All right, other thing we're looking at today is the quotient rule. So the quotient rule tells us that when we are dividing like bases, we keep the base the same and we subtract the denominator exponent from the numerator exponent. So what that means is if we have x to the power of a over x to the power of b, that equals x to the power of a minus b. So we just subtract the exponents. So for our first example, we have x to the power of 6 over x squared. So we are going to take that and say that's equal to x to the power of 6 minus 2, which equals x to the power of 4. So all I did was subtract the numerator and the exponent, that's 6, and subtract the 2 from the denominator. And that's your final answer. A little bit more complicated is number 4. We have 24x to the 7th y squared over 16x cubed y to the 4th. So first, if I'm looking at that 24 and the 16, they're both divisible by 4. So I'm going to just divide 4 out of each of those. So 24, actually they're both divisible by 8, so we'll just divide 8 out of each of those. 24 divided by 8 is going to leave us with 3. 16 divided by 8 is going to leave us with 2. So that becomes 3 over 2. We have x to the 7th over x cubed, so that's going to be x to the power of 7 minus 3. and then y to the power of 2 minus 4. So this becomes 3x to the 4th, y to the negative 2 over 2. But remember, we can't leave a negative exponent in our final answer. So we have to go back and use what we know about negative exponents to make this positive. So we are going to take that y to the negative 2, and that's actually going to get moved to the denominator. So we still have 3x to the 4th in the numerator. Denominator, we still have that 2, but we moved that y to the denominator, and it's going to be to the power of a positive 2 now. So that is our final answer.